Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And I'm Philip Sage from beautiful Victoria, Australia.
Well, I'm in what today is sunny California, and we were just recording another show. And Philip, you kept bringing up, are we working on the right things? And there's so much to that topic. I kept trying to change the subject back to the other topic we were talking about, but I just hit record. So, I mean, there's something behind this. What are you talking about working on the right things? Don't we work on what the boss tells us to work on, or what our job description says? Isn't that enough? I'm being facetious.
Well, I think, obviously. Yeah, in the broader sense of things, I think often we're not working on the right things, and that opens up kind of Pandora's box as to what should a reliability engineer be working on. And we might start that discussion by just listing a litany of different things that we know that reliability engineers do work on. But as we look across the entire food chain of an organization, it's not always the elimination of failures or the developing the greatest asset strategy or having the best predictive maintenance program that provides the impact to the organization. As we see even from the certification opportunities that are available to reliability engineers, like the certification of the CRE, Certified Reliability Engineer, offered by the American Society of Quality, or the Certified Maintenance and Reliability Professional offered by SMRP, or the Certified Reliability Engineer Leader, offered by the Association of Maintenance Professionals. There are different niche areas of certification. And so there are different, it's fair to suggest that there are different areas of specialization within the reliability engineering field. And where we are working, we need to ask the question, are we working in the right part of the organization or the right process to make the biggest bang for what our capabilities as reliability engineers are?
One of the things, when I was at Hewlett-Packard, I had the opportunity to do a reliability assessment of as my predecessor called them, the loosely affiliated feudal baronies of the divisions of the company. There's a division that made inkjet printers, and there's another division that made calculators, another division, and so on. So a lot of the bigger product lines were a division, and there were a gazillion of them. And we didn't have reliability engineers in the product teams. They just was not a job title that was common in the organization. There was probably on the order of 50 people out of the tens of thousands of engineers. Yet, every single organization I approached, I asked, I need to talk to somebody that deals with the reliability of your designs of your products. And every single organization put me in touch with somebody that was in name or in theory in charge of that. And so what I found was that people that were a manufacturing engineer or a supply chain engineer or even a marketing manager were deemed the lead or the sphere for the reliability effort. It didn't really matter what their job title was. They cared about creating a product that met the reliability requirements and took steps to help the rest of the team do it. They acted like what you and I would call a reliability engineer. In plants and in facilities, it could be a manufacturing engineer, it could be a maintenance tech. It really could be across the organization of anybody that worries about uptime or maintenance of the equipment and serviceability of the stuff, buying the right equipment and so on. Can make a difference in the world of reliability engineering. So I find part of the problem we have is working on the right things is we may not be in the right title or in the right department. There's plenty of people. When I was at my first position at HP, I was a manufacturing engineer supporting a development team and ended up doing a whole lot of reliability stuff. Because I found the argument, and this is where I think you're going with this discussion, is I found the argument that improving throughput by 3 seconds per unit, yeah, you could add up some money for that. But if I could reduce the failure rate from 2% to 1%, and because of the volumes we were making, that was tens of millions of dollars. And the program manager said, "Oh, that's important. Let's do that."
Yeah.
Kind of thing.
Yeah. Spot on. And I think that really kind of underscores the nature of the discussion topic today, in that if we're already pretty good at the failure performance, or we've already got a very good asset strategy that combines preventative maintenance and predictive maintenance and inspections and what have you to keep the asset operating, and it's fairly available. Working on those things is always, we call it a journey, but it is a journey into the land of diminishing returns. And it doesn't make any sense, just to provide an illustrative example, to have an availability of 92% on a batch process, which would typically be considered first quartile performance in my experience around the world, when our first pass quality is at 60%, meaning that 4 out of 10 items we have a defect and we have to sell in a secondary market, or we have to remanufacture or repair before we can ship them. So, the reliability engineer in that particular scenario really shouldn't be working on a compartmentalized function of improving reliability, or that contributes to the availability, especially if the first pass quality is at 60%. We should all be working more like the theory of constraints, where we consign all of our resources against the current bottleneck.
Yeah.
If we're truly being bottlenecked or hampered by that quality problem, then the reliability engineer, rather than Weibull analysis on failure data, really needs to shift gears into run charts and statistical process control, and understanding where the key input variables are and the effects on the key output variables of quality.
Oh, can you imagine, you sit down and do a Weibull chart, right? And you have like this week's run, and you're plotting out how much of the stuff has, gone to the field and survived over this period of time and stuff, but only half ever actually got to the field. So do you include that stuff that got reworked or resold a different way or something else? Do you count that as sensor data at time zero, or what would that do? So I'm just boggled, and if you're forced to do the analysis, I start doing it, with, all right, let's assume all of these are out of box failures, and that really makes our field failure rate look really, really bad. And they sit up and go, oh, well, why do we have half of them not get out of the factory? I've actually had a similar discussion as that one time. And they actually told me, no, we like using MTBF because it makes our reliability numbers look better. Okay, that's another whole topic there. But part of it is some of it is a lot of what we do. It's training and teaching and mentoring, right? It's, let's not use this measurement system or this metric or this, let's track these KPIs when they're actually counterproductive what we're trying to do here. If we're trying to create good quality products and on time and all those things, what we're doing over here of how many failures, how fast we do field failures, or how fast we put a machine back in service may not be actually useful for us, because we're back out there tomorrow fixing it again. We're getting really good at fixing it fast because we do it a lot.
Right.
It's kind of counterproductive here, guys. Let's think about this. And another whole different topic here, Philip, another whole piece of this is, I was working with a company, and it was a small handheld product that we're working on. Wasn't expected to have huge volumes, but it was to complete an overall portfolio of a product offering they had. And by absolute chance, I sat down in the lunchroom next to this a couple other people, and one of them introduced herself as she works in the finance group, and she asked where I worked, and I told her about the project, and goes, oh, I work on that project. That's coincidence. I work on the finance side of that exact project. And I said, for a couple months now, I've been trying to get all of the test data from the previous runs of this product, iterations of this product, but nobody seems to know where it is. If anybody does, you might, because you're probably paying the bills for it. He goes, yeah, I get that bill every month, and you can't get the data. I'm paying for it. And so she helped me she stopped payment on the stuff. And all of a sudden the data became available. And it was, and the guy that I talked to I'm quite sure he was in some basement in some factory in China. I knew he was in China. And he said, I've been doing this for 5 years and nobody's ever asked me to see this data. He says, well, you're one hard person to find, But it was one of those things where they were collecting all of this data. They were requalifying this product every month with an insane number of samples they would take off the line to go do this. And it cost tens of thousands of dollars per week to do this. And in that one discussion, by chance, with this person from finance that we happened to be working on the same program, saved him over the span of the year I was there, over $2 million.
Yeah.
And it was just, why am I not working on this? And everything else I did, my boss asked the guy that was my supervisor or boss, he said, why are you working on something like that? That has nothing to do with reliability. I says, do you want to save the millions of dollars or not?
Yeah.
There's something broken in the system here. Let's fix that. And that kind of went up the food chain then is you spot an issue, whether it's, I don't have the right spare parts for this project. How come this isn't getting kitted out right? All the way to, why can't I find this data? Both could lead to systemic changes to the great benefit of the organization.
Yeah, it really is at the core of problem solving, which I think is at the core of the mission of reliability engineering, is to solve problems. And we want to make sure, and it's a good topic to discuss, I imagine when we get back into the lunchroom with our colleagues or with our boss at that opportunity in the team meeting, are we working on the right thing?
Well, how do you judge that, though? I've talked about a couple of random examples that turned out to be really good. And there's plenty of dozens of examples that I'm not going to talk about because they didn't turn out all that good. But how do you know if you got 47 different things you could do, which one's the right one to do?
That's a great question. And I think it depends on the assessment of the situation that you're in and where that impact is at. The example I think I gave earlier of having an organization that's generally got reliability under control, it doesn't make sense to work on the governance of master data anymore or asset strategy management to improve incrementally your PM or your predictive maintenance program effectiveness. The bigger bang for the buck is really to focus on and make sure that your first pass quality is reasonably aligned with the quartile that you think that your overall organization's at. And if it's not, then that's the area to focus on because that's going to deliver the biggest bang for the buck. Well,
that's a A/B comparison, but there's also C's. Like this one organization decided that every new piece of equipment they bought that did a very similar function was from a different vendor because each time they went out to bid, and so they had 15 pieces of equipment that were incompatible with each other. You couldn't buy a bearing the bearings only fit one machine kind of thing. You imagine all the storeroom issues that caused and all the supply chain issues that caused just for parts and training. There's people that were on the staff that were only trained on 6 of the 15 units, and they couldn't work on the one that actually broke down today. But sticking my nose into that one, I got it slapped by the process and the governance folks and so on. And I went back to him and said, this is how much it's costing you. Yeah, you get a lower bid this time, but seriously? Come on.
I had the good fortune of working in the steel business that had been through that. Value engineering was the term that they used to go out to market and accept the lowest bid most often. And the purchasing department, purchasing function was very proud, and many are still engaged with trying to find the lowest price point.
Yep.
And aren't often aware that of these problems because they don't live in their arena of focus. But one of the reasons that the mini mills took over the United States was the way that they were bid. And whether it was an electrogalv line or a hydrochloric acid pickling line. The equipment was bid on a particular mini mill that I'm familiar with, was bid on 8.5 one sheet of paper, and the requirement was that the entry end equipment all be identical, even though they were buying 3 entirely different processing lines. Uncoiling steel was the same, and therefore the entire entry end and all the electronics, all the mechanics were all the same, and the bearings were all the same. And so you ended up with a much simpler task in the storeroom. I was blessed with 15 different technologies that had gone from simple Ascania systems and magnetic amplifiers all the way through advanced SCR controls and MG sets and field regulators as I grew up in my career in the steel business. And I guess the good thing was that I had to learn all of that different equipment. The bad thing was I had to learn all of that different equipment.
That's right. You're spending all your time just trying to figure out what part do I need? How does this work? What's the theory here? What can I do about it?
And each manufacturer's prints were different. How you move between pages on a circuit to follow a problem, different types of logic and voltages, and even with the early computers, dare I say, we had paper tape readers and some of the other early equipment that went into computerization, like core memory, which today would be in a museum or removed from a museum because nobody would visit the exhibit. But,
right.
We had the opportunity to work on all those things. So I think, it gets down to, from a reliability engineering perspective, are you working on the right thing?
Well, to me, to answer that question is if I spend an hour working on something, what's the return on that investment? It's basically back to the finance folks and, and investors type stuff. They want a return. And if I'm working on, like you said, just polishing the strategy and the one more thing and goes into predictive maintenance. But if that only is going to return $10,000 a year, it's not worth much of my time to work on that. As opposed to if I could get the supply guys to actually change their bidding process so that they fit into the existing stocks and storeroom and maintenance training. And sometimes all that takes is, this is what this costs. If we have a separate type of system that uses unique tools and training, it's not in the price tag that you're bidding on, but it's a real cost to the organization. And more than often, as a reliability engineer, they says, well, you're a reliability engineer. You have nothing to do with supply. And I says, yes, I do. And if you don't believe me, I'll go talk to somebody in this organization that cares about that. And here are the numbers. And then, do you want me to tell your boss or should I? And, I don't know how many times I won that argument of, 10% over the, year over year cut in prices of components is not always a good strategy. And eventually somebody's paying for that mistake. And I find that my role in those cases is just education. Here's the impact of what you're doing.
Yeah, and you could even develop mathematical probabilistic models that show that as you make spares less available, that the overall unavailability of the process drops and the reliability drops, and all of those things are interrelated, even at a not only at a high level concept, but when you focus on the individual details and build models and make adjustments to the logistics delays, even the PR to PO conversion time of an organization impacts the overall reliability and availability of the process that it supports. So working on the right thing is going to be different for everybody, but I think it's a very valuable question to ask in a team meeting. How do we know that we're working on the right thing? And maybe that type of a question will spur the discussion that will help you justify that you are working on the right thing, or maybe open some new horizons that you should be working on the other end of the food chain. And that may be focused on data governance or asset strategy management or improving the predictive program, all the way up through improving availability and finally to achieving a better or higher improvement in your first pass quality.
Yep.
And all of those things are the areas of work that a reliability engineer can and should be involved with. And what's important is to make sure that we're not being pocketed into a very limited role in the wrong part of the food chain, because that's the way it's always been. A reliability engineer, in my mind, should be moving to the area of greatest need.
Yep. And I look at it as that need part is really what's the expected return on investment. You got to do your homework. And one of my often said in this podcast is get to know the finance people. Bring them a question you need them to go explore for you. They've got all the numbers. They know what all those fields mean and all that good stuff. And I haven't found an organization yet that the finance guys really like doing the exploratory stuff where what's the expected ROI on this investment or that investment. They kind of eat that because it's not the normal stuff day in and day out, opening, keeping ledgers and all that good stuff. They like, helping you figure out, is this the right thing to work on from a financial point of view? Now, financial isn't the only criteria in organizations, but it's a pretty powerful one. And so, and it's not just saving money in the organization. It could also be increasing sales. There's links between the product is reliable and your customer service is competent and very good at what they do. In other words, and increasing sales. So you can justify doing the right thing in those areas because you increase the sales and the word of mouth improves and all those kinds of things. So yeah, I don't limit it to any part of the organization that can make a difference and an impact to the customers and to the organization. It's fair game for a reliability engineer.
Yeah, and it's not, it is probably uncommon, but it's not unheard of. I was once involved with improving the first pass quality, took it from about 60% to almost 95%, and that caused a pretty interesting problem in that we had a big secondary market where we sold 4 out of 10 items.
Yeah, now you had no supply for that.
We had no supply for them as a result of improving the reliability of the equipment that processed it. So, reliability and removing variability and the manufacturing process are all hand in hand. And I think too often we focus on that little niche area that we need failure data and we need to do Weibull analysis or root cause failure analysis. And those are just tools in a very big toolbox. And the focus of a reliability engineer really needs to be on the right thing and with the right tool set.
Yep. Yeah. No, well summed up right there. If you're listening to this, it's, I guess my question to you is are you working on the right thing? And how do you know? And if you've got a dilemma or a problem you've run into, or you've got some ideas or suggestions of how to help yourself and others get to the right thing, let us know. Head over to accendoreliability.com/go/SOR, and you can find a couple of ways to get in touch with us there. I actually got an interesting email yesterday from a listener, which will very likely make it into a future podcast. It was on FMEAs and a kind of a unique scaling system they were proposing, which I thought was interesting. But I digress. Philip and I and the other hosts of the show are available through LinkedIn and or through our individuals' about pages on Accendo. And we really do like hearing from you. We get all kinds of cool ideas for future episodes. Plus, we try to get you an answer or comments back right away so you can keep on doing what you do. And hopefully it's on the right things. So we'll go with that.
Yeah. And what SOR number is this, Fred?
Roughly, this is going to be, when it comes out, will be 842.
Yeah, wow, 842 different podcasts about reliability. Speaking of reliability, and I don't think we'd even ever consider talking that much about the topic if it wasn't for your feedback and questions. So please do provide some feedback. And with that, Fred, I'll turn it back to you to put the ribbons on it for this time.
Well, I think that's it. We're done. All right. Thanks, Philip. Thanks for bringing the topic in. I knew the last episode you just wanted to talk about this one.
Yes.
We'll talk to you again soon, Philip. Take care.
All right. My pleasure. Bye now.
Bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.